This system here has 70 features. We've interacted with an LLM about 5,000 times in order to get this information. So for a user to do that themselves, that would mean writing 5,000 prompts to an LLM and putting in 5,000 versions of context in different, and by that I mean this code file or these functions in different manners.
Chris just revealed something super interesting about AI development. What often looks like one feature actually requires thousands of interactions. And the more you add, the less you focus. Language models have what Chris calls an attention problem. Load too much context and accuracy degrades. Too little and you'll miss the critical dependencies. The solution? It's a new architectural pattern where different tools handle different complexity levels.
AI models have a concept of attention, and the more context they need to pay attention to, the less likely they are to be very accurate about what you're asking them to do. Let's say we've just built this insurance claims screen and I click on this row and it wasn't popping up this dialogue properly. And I told it, hey, come on AI. I've told you, let's make this, let's get it working. And let's say maybe it fixes it, but it might actually break something else on this screen. So you're taking one step forward, two steps back. I actually got a friend who has a company that is based on helping people when they get to the point where V0 or Lovable, they can't do it anymore. It's breaking and they need someone's help. So they've made like a vibe coding repair agency, which is very interesting.
A repair agency for AI-generated code. This isn't a bug. It's the emergence of a new service layer. When AI hits its attention limits, specialized humans will step in to navigate that complexity. It's creating new job categories.
From 0 to 80% really fast. And then there's other ways to fill up that 20%, which I would recommend. How we do it is you eject from these platforms and you use something like Cursor or Windsurf or Claude Code, many of these like AI editors, and then a software engineer can use AI to help you get to that last 20%.
Notice the precision here, 80% in V0, then eject. Download the code, transition to Cursor or Windsurf. This isn't random. At 80%, you've exceeded V0's attention capacity, but haven't yet reached Cursor's limits. Each tool has an optimal complexity range.
You know, some software is so simple that you can keep it all in your head and you can imagine how it works. And then you could say, well, maybe you don't need user.doc. You could just come to V0 here and you could make me a social network for dogs or whatever it is, right? And it would come back and give you something. AI is always going to be correct. It wants to impress you. It wants to do your bidding, right? The thing is, like, when you have a tool that a business needs stringent requirements on, like the business already knows what they need, they've spent time, and so this is the waterfall piece. They've spent time confirming this across the different stakeholders who need to. I think the reason that it was such a backlash against waterfall was because companies would spend a year putting together a 500-page document, and then inevitably they'd find out after 2 years of development that it didn't work. Behind the scenes, we build a knowledge graph of all the code and all the interdependencies and relationships between the code, how they relate. We use some static analysis. So it's not all AI. We actually use static analysis to understand the different code and find relationships. We then build like multiple iterations in like an agentic fashion, agentic fashion of different reviews of the code. We actually model it on what humans would do.
Static analysis plus AI agents. This hybrid approach manages attention by pre-processing relationships before the AI sees them. It's how user.doc handles millions of lines of code without hitting attention limits.
There is a point, unfortunately, where that point is very hard to tell you because it's very system dependent. But there is a point where AI will start to be more reliably unreliable. It will start to consistently make mistakes. Two ways of doing it. I think looking at something like V0, it's a great way for if companies want fast prototypes, visual feedback, really get the look and feel of it, then it's a great way to move really fast with that. I would recommend, especially for systems where security is paramount, you're dealing with important data, you don't want to vibe code those systems today. That's my view on it. Some people have different takes, but I think my experience as a software engineer for 20 years working on those big important systems is I would always have a level of governance and rigor around what you're actually going to be deploying.
Chris has revealed the hidden architecture of AI development. It's not one tool, but an orchestrated stack, each handling the complexity levels it can sustain. UserDoc manages requirements through 5,000 micro interactions. V0 then takes you to 80% with visual development. Cursor handles the final 20% with code level precision. The breaking point isn't a failure, it's a signal to transition tools. This creates a development pattern. Start high, abstraction, and progressively move lower as the complexity increases. The developers who mastered these transitions, knowing when to eject, when to switch tools, when to bring in human expertise, they're building the new default.